This is a partial explanation of the Archimedes spiral and how it has or can be used to find a triangle with an equivalent area to a given circle. And using Geometry Sketchpad, I made sure that my graph is in polar, and then I just made an arbitrary segment, AB is the name of mine, and just measured it. It is has a length of 0.60 centimeters, and I will use this segment to create a spiral by going to Graph, Plot New Function, and it will be AB, whatever that segment is, in my case 0.6, times theta. I will then divide that by 1 radian, and it will give me this equation here. That equation has already been graphed. It is the purple spiral that you can see here. And from that, I'm going to construct a circle. That circle will have center E, the same point where that spiral begins, and it will have a radius that goes from E to the location where the spiral intersects the vertical axis below the horizontal. And I'm going to place a point at that location. And then I will draw a segment from E to that location. And that segment is highlighted. I will mark E as the center of my circle, and there is the circle I'll be looking at. That green circle is my starting point, in the sense that that is the circle I'm going to use to construct a triangle with equivalent area to it. And the first thing I'm going to do is find the area of that circle, and it's 25.4 square centimeters. Once I know the area of that circle, I will then attempt to make the construction of the triangle, and what I'm going to do is show the hidden point that I've already predetermined to be the location where that triangle's hypotenuse intersects with this horizontal axis. And that point D, in this case, I will create a line that goes from D to this point here, and there's the line that I'll be using. I am now going to highlight my vertices. That will allow me to instruct the interior of the triangle. Once I have my interior constructed, I am able to find the area of that. And you can see now that the area of that triangle that I created, triangle DJE, is equivalent to the area of my circle. If you wanted to clean up the look of this diagram, you may. Although you already have constructed a triangle that has an equivalent area to the circle, it might have a little nicer appearance if you did some hiding of certain objects. Before I hide that hypotenuse line, though, I do need to construct a segment between D and J, so that when I hide the line, there's still that segment between D and J visible. If you want to, we can hide the grid. We can hide the axes. I will need to construct a segment between D and E, however, and I can hide these 2 points that are not needed in my construction. If you'd like, you can add a little interest to your project by adding some animation. One way to do this would be to simply add a point on your spiral and go up to display. We're going to label that as a trace point. I am going to, before I begin tracing, hide my function plot, and so the spiral is not in view, I will then go ahead and ask it to animate. And voila!